Welcome. This is video number 437. In this video, I'm going to explain the preference relation in consumer theory. The preference relation plays a very crucial role in the theory of choice and consumer theory. Formally, the consumer preferences are represented by a binary relation which are defined on the consumption set X. If bundle X1 is better than bundle X2, we say that X1 is at least as good as X2 for this consumer. The following axioms set forth basic criteria with which those binary comparison must conform. Axiom number 1 is that of reflexivity, and it means that for any bundle X in the commodity set X, X is at least as good as itself. The second axiom is that of completeness, and it means for all X1 and X2 in the consumption set, either X1 is at least as good as X2 or X2 is at least as good as X1. And it says that the consumer can examine any two distinct consumption plans X1 and X2 and decide whether X1 is at least as good as X2 or X2 is at least as good as X1. And the third axiom is that of transitivity, and it means that if there are any three elements X1, X2 and X3 in the consumption set, then if X1 is at least as good as X2 and X2 is at least as good as X3, then transitivity means that X1 is at least as good as X3. Preference relation, the binary relation of at least as good as on the consumption set X is called a preference relation if it satisfies axioms 2 and 3. There are two additional relations that we will use in our discussion on consumer preferences. Each is determined by the preference relation, and they formalize the notions of strict preference and indifference. First, we discuss strict preference relation. So, the binary relation, this binary relation on the consumption set X is defined as follows. Bundle X1 is strictly preferred to bundle X2 if and only if X1 is at least as good as X2 and X2 is not at least as good as X1. This relation is called the strict preference relation induced by at least as good, or simply the strict preference relation when at least as good relation is clear. The phrase X1 is preferred to X2 is read X1 is strictly preferred to X2 bundle. Then we have indifference relation. The binary relation denoted by tilde on the consumption set X is defined as follows. Bundle X1 is indifferent to bundle X2 if and only if X1 bundle is at least as good as X2 and X2 is at least as good as X1. This binary relationship is known as indifference relation, and this is called the indifference relation, which is induced by the at least as good the relation, or simply the indifference relation when this relation is clear. The phrase X1 is indifferent to X2 is read as X1 is indifferent to X2. This is X2, not at least as good as X2. For any pair X1 and X2, exactly one of the three mutually exclusive possibilities hold, and that is X1 bundle is strictly preferred to X2, or X2 is strictly preferred to X1, or X1 is indifferent to X2. So then we have some sets which are derived from the preference relations. Let x naught be any point in the consumption set X. Relative to any such point, we can define the following subsets of X. Number one, uh, at least as good as X naught, and that is the set of X bundles such that X is in the consumption set, and X is at least as good as X naught, and this is called is at least as good as set. The second subset, the second set is uh, no better than set, and no better than set X naught is a set of X bundles such that X is in a consumption set, and X naught is a no better than X bundle, and this is called the no better than set. The third set is worse than X naught, and that is a set of X bundles such that X is in the consumption set, and X naught is worse than X bundle, so this is called as the worse than set. Then we have preferred to set, and this relation preferred to X naught is the set of X bundle such that X is in the consumption set, and X is preferred to X naught bundle, and this is called the preferred to set. Finally, we have the indifference set, and for this we use tilde. So here this is a set of X such that X is in the consumption set, and X is indifference to X naught, and we call this the indifference set. A hypothetical set of preference satisfying axiom 2 and 3 has been sketched in this figure, where X is in the non-negative orthant, and these are the various relationships at any point in the consumption set, such as X naught, which consists of X1 superscript 0 and X2 superscript 0, represents a consumption plan consisting of a certain amount of X1 naught of commodity 1 together with a certain amount of X2 naught of commodity 2. Under axiom 2, the consumer is able to compare X naught with any and every other plan in the consumption set and decide whether the other set is at least as good as X naught or whether X naught is at least as good as other. Given our definitions of the various sets relative to X naught, axiom 2 and 3 tells us that the consumer must place every point X into this relation, into one of the three mutually exclusive categories relative to X naught. Every other point is worse than X naught, indifferent to X naught, preferent to X naught. Thus, for any bundle X naught, the three sets that is worse than X naught, indifferent to X naught, and strictly preferred to X naught partition the consumption set is this. Now we discuss convexity and strict convexity. If bundle X1 is at least as good as X naught, then the combination Tx1 plus 1 minus Tx naught is at least as good as X naught for all t in the interval of 0 and 1. A slightly stronger version of this is the following. Strict convexity: if X1 bundle is not equal to X naught and X1 bundle is at least as good as X naught, then the combination, the convex combination Tx1 plus 1 minus Tx naught is strictly preferred to X naught for all t in the interval of 0 and 1. Ladies and gentlemen, this is a brief discussion about consumers' preference relation. I hope this is interesting and informative for you. Kindly subscribe to the channel and do not forget to click on the bell icon so that you can get regular notifications about my other videos that I'll upload for you. I thank you very much for watching this video. Kindly subscribe to this channel and share its various videos in various WhatsApp groups. Thank you and